Welcome everyone. Welcome to part 2 of our advanced GIS methods training course looking at internet user classification and k-means clustering. Today we're going to look specifically at k-means clustering and how we can use it for internet user classification, but also how we can use it for our own geodemographic classification. So I'm joined by Dr. Jacob McDonald from the University of Liverpool. So Jacob, great to have you here.
Thanks, great to be here.
Cool. So Jacob's going to take us through some of the process by which we create the k-means clustering and how he did it and how we can actually apply it to different data sets. So we're going to cover, quite a few different things, but very much focus on the practical side of how we actually do this, and this will be really useful for the workbook that you can do after this presentation. So Jacob, could you give us a little bit of an overview of the internet user classification and how it relates to the k-means methodology?
So the internet user classification, it's a geodemographic that looks to classify different areas across the UK according to how people interact and live and use the internet in that area. So the way that it's built is using the k-means clustering. There's a series of input characteristics that define certain areas, which are in this case the LSOA, and using these attributes of the given area, which relate to internet use and infrastructure, we come up with a classification using the k-means to classify the area based on the range of these underlying inputs data.
Great, okay, thanks. So there's quite a bit to unpack in there. So the first step is what data goes into this. So what data did we use for the internet user classification?
So primarily what we were looking to do was to classify areas and geographies based on the internet usage and the internet infrastructure. So we want to look at things like how people are interacting with the internet, the types of broadband speeds that they have, the usage of the demographics in the specific area. So a lot of those input variables were coming from the British Population Survey, which is a CDRC product that we have. And that defines a lot of the kind of demographic use of the internet. But then we do also include a lot of infrastructure download speeds related to kind of internet use, which comes from Ofcom. So using a range, there's many number of input variables going into this, all based around the usage and the infrastructure. And using this range of variables, that's how we come up with this classification of categories.
Okay, great. So as I understand it, some of the internet usage data from Ofcom was probably at postcode level, and the DPS stuff was at LSOA, and the final output is LSOA. Why do we use LSOA for a lot of these outputs?
So first off, yeah, if you do have data in different geographic scales, for example, some of the download speeds and broadband speeds come both at the postcode and the LSOA. There's different versions. The first thing important to make sure that you're using consistent geographies. So whether you aggregate up from the postcode or you're just using directly the LSOA, we want to make sure that the different input variables are all measured at the same geography. And then in terms of the selection of the geography, we know there's lots of different scales and different kind of boundaries that can be used here in the UK specifically. We use the LSOA in part due to a reason of granularity. So it's a fairly small geographic unit representing a few blocks in an area, but also in part due to the fact that most of the statistical data and a lot of administrative data in the UK is based or kind of revolves around this LSOA geography as well. So we wanted to make sure in developing a product that we would be able to kind of put this product out in the most accessible way possible so that it could be used alongside other data products or geographies that are existing already.
Okay, great. So, you know, it's quite important to think about what your classification is going to be used for, even at this point. Think about what's the best way of putting it together.
Yeah, exactly, right? So we want to kind of get a scale of, you know, how granular are we looking to define these groups? Where would we kind of expect to see patterns? And then, of course, the available data.
Mm-hmm. Great, thank you. Okay, so how do we actually go about running the k-means clustering once we've got all our data in and organized in the geography we want?
I would say, yeah, the biggest step to all this is formatting the data, getting everything into kind of the cleaned database. So we want to make sure that we have all of our observational units cleaned in a kind of row format. In this case, our observational units, like I said, are the LSOAs. And then for every LSOA, we're going to have a range of different input variables. And then in the case of the Internet User Classification, like I said, these are kind of based on infrastructure and more kind of internet usage type variables. But we can have any number of variables, right? So the number of variables that you're choosing, the number of inputs that you're choosing is going to kind of depend on a lot of the research question and the data available, some of underlying theory. But once we have a set of input variables that we want to kind of feed into this this algorithm, then essentially what we want to do is to take these input variables and look at the signature of all these attributes across LSOAs and kind of cluster based on that signature of input variables. So what we're going to do is to look for LSOAs that have a relatively similar statistical mean to that group of clusters. So, we're thinking multidimensionally here, but what we want to do is to kind of cluster, we want to make sure that groups of clusters are as similar as possible in terms of all of these input variables, and also as dissimilar as possible from other clusters. So it's kind of like a hyperparameter clustering on all these inputs.
So in terms of how the inputs are arranged, we could think of it as a, if we were just dealing with 2 dimensions, we could think of it as a kind of graph, and we have clusters where we want to have LSOAs that are close to each other, but we then extend that to 3 dimensions, 4 dimensions, or however many dimensions for however many input variables we have.
Exactly, right? So if you're thinking of an X and Y axes, you would see physical clusters. And then, 3rd dimension, you'd kind of have spheres, but we can increase the number of parameters as much as we want. And what we want to do is kind of on the whole of all of these parameters, let's consider the signature of all of this kind of cross section and kind of group in this high dimensional space, not just on how many people are using X amount of internet, but also on the broadband speed, on the local characteristics. So in this way, we're able to condense a lot of information down into, into one classification.
Okay, great. No, that makes great sense. Thank you. Okay. So we do the cluster analysis in R, and then we get this elbow plot. So how do we work with the diagnostics, and then how do we actually choose which model we want?
So one of the limitations or things to be aware with the k-means clustering is that beforehand we need to select the number of clusters. So going into the modeling, we need to choose whether we're going to want 2 clusters or 3 clusters or 4. And a lot of this can come from kind of knowledge beforehand into the research question and just knowing the context. But because there's a little randomness in selecting this number of clusters, what we want to do is to actually run as many of them as possible, up to 8 or 9 clusters, for example. So what we tend to do is to kind of iterate through, and we'll estimate the model with just 1 or start with 2 cluster groups. So we'll take all of our input variables and we'll look what happens when we break it into just 1 and 2. And then we'll break it into 1, 2, 3, 1, 2, 3, 4, and these are kind of different models with different clusters, and clusters here are the K. And then what we want to do is to evaluate each of these models based on some underlying diagnostics. So like I said before, the idea of the k-means method is that we want to make sure that all of the cluster groups are as similar as possible in terms of the high dimensions of all the input data, and are as dissimilar as possible from all the other cluster groups. So if we put everything into a cluster group, all the observations there should be very similar, and they should be fairly different from any other observation not in that cluster. So what we can do is to actually evaluate how much this variation within the cluster group is. So if we have too few clusters, say for example, we're only clustering into 2 big groups, when in fact there should be 5 or 6 groups, what we're going to see is that the variation within the small amount of clusters is too high, so that the observations all within group 1 are just very dissimilar from each other. And that tells us that there should probably be more than just that one cluster. So that's exactly what that graph down in the right-hand corner there is showing us, is that this WSS, which is the within sum of squares. So this is a measure of, if we just have one cluster, what is the, this is a measure of variability, but what is kind of the average variability between all the observations in that cluster? And you can see with one cluster, we're going to have a high amount of variation within all of the cluster sphere. With 2, we're going to kind of break that up, and we'll have a fairly lower amount of variation. And you can see as we add more and more cluster groups, the clusters are going to become more and more similar to each other. So what we want to do is to get rid of all this high variation within the small number of groups. And we want to pick a number of clusters. So this is essentially just to give us what number of clusters we want to use. This is the diagnostic we're testing. And so we'll want to kind of pick the number of clusters such that the variation within the group is minimized, or at a kind of a minimal point. But we also don't want to be overfitting. So we want to kind of just reach the minimum number of clusters necessary to minimize that variation without splitting up the observations anymore. So this, if you look at that plot there, we can see the variation kind of decreases up until about the 3rd or the 4th cluster. So what I would do, I would kind of go ahead and pick somewhere between 3 and 5 clusters here. That's kind of showing you that at that number of breaks in your data, the variation, conditional on all your inputs, is going to be kind of minimized.
Great. Okay, so we've done our diagnostics, and we've picked somewhere between 3 and 5 as the number of clusters. So then we do the cluster analysis, and it actually gives us the 3, 4, or 5 clusters we have. And what's the kind of final step after that?
So you'll input your data. You have your kind of matrix of all your input data. The k-means algorithm, after you select the number of clusters. So let's assume we're kind of coming up with 5 clusters. We kind of did our diagnostic plots, and we select 5 clusters as being, the appropriate one for our data. Then what we want to do next is to output the clusters. So every observation, which in the case of the Internet User Classification will be an LSOA, every LSOA is going to get a number essentially from 1 to 5, indicating whether it's in cluster 1, 2, 3, 4, or 5. And so every observation in cluster 1 is going to have input variables that should be very similar, or with the lowest amount of variation. And so we can actually check this. So we can take the cluster outputs that we would get, so the LSOAs, the cluster assignments for each LSOA, take that back to our original data. And then what we're going to be able to do is to actually look at the input data for every cluster. So we can see what is the average input data. Say for example, we have 5 or 6 variables that we're clustering on. In the Internet User Classification, it's well over 30, 40. It's quite large here. So say for example, we have 4 or 5 variables that we're finding to be important. That's what we're clustering on. Then what we can go is to look at what is the mean value or the median or any kind of descriptive statistics for all of those input variables in cluster 1, cluster 2, cluster 3, cluster 4. And that's going to shed some light essentially on what these clusters are. So why are the observations in cluster 1 assigned to cluster 1? Well, we're going to be able to see that, you know, variables 1, 2, and 3 are very similar. We can look at the mean value, the median, whether it's positive or negative. So that's going to be able to, you know, just using those descriptive statistics, give us kind of an idea of what these clusters are based on our input data. And then we can kind of take it a step further and, you know, assign some meaning to these clusters based on this data.
So with the internet user classification, you know, for example, you know, it might be we have, say, I don't know, internet speed and percentage of users with super fast connections and 2 or 3 others, and we'd look at the means for those different values for each of the clusters, and cluster 1 might have a very low average speed. So we might say that cluster of people with low speed internet who can't access faster broadband or something like that, and develop it more with the extra data.
Exactly. And if you go to the CDRC website, you'll see exactly this kind of portrait document laid out for every of the clusters. There's about 10 clusters. And, you know, all of that is done, you know, in consultation with industry experts, knowing your data, knowing what inputs go into that. You can just look at the descriptive statistics and, you know, put some context and meaning to the cluster groups. And, you know, that's going to tell you essentially what the different geographies are, right? Do you have isolated people? Do you have people with good access, but are, you know, different demographics? All these differences you can pick out from the pen portraits.
And as we are geographers, would we also look at the spatial distribution of the LSOA in each cluster, and would probably kind of aspects to do with how urban or how rural different areas are come in as well?
Exactly, right. So we're not explicitly putting any kind of space into this, but the LSOAs are a spatial object. So we can directly map those onto the map. So if you look at the CDRC map, for example, that's exactly what we have. And then that's going to shed an even, you know, another layer of information, because we're going to be able to pick up whether cluster 1 are spatially clustered as well. So do we see kind of patterns in where specific clusters are? And that's the thing that we can pick up, you know, what types of clusters are in city centers versus rural areas. So mapping this data is going to add a whole other level.
Okay, no, that's great. You know, this is a little bit beyond the kind of topic we're talking about now, but if we wanted to incorporate space kind of more explicitly, what are the sort of methods we might do with that?
So the k-means on its own is not a spatial clustering method. So it's not based on, you know, density of observation or points. So for example, a DB scan clustering is going to be like a density based point cluster. Here, what we have is observations. So this is, in our case, an LSOA or a neighborhood, but it doesn't have to be. It could be a person, it could be a firm, it could be kind of, you know, anything. In the case of the LSOA, it's spatial in nature. So we are in some way applying the means to a spatial object, but we're not including any kind of spatial data per se explicitly. One thing we can do is that the good thing about the k-means is very, very flexible in the types of input parameters that we use. So we could, for example, choose to put space into the clustering as an input parameter. So to give you an example, so I've been working on some products with housing data. So again, at the neighborhood LSOA level, not only do we want to cluster on demographics, but we also want to cluster on trajectories of how fast that neighborhood has been growing over time and how strong the surrounding neighborhoods have been kind of growing over time. And so there's no explicit spatial methodology embedded in the k-means algorithm. But if we do put in variables like a spatial lag or a spatial, you know, an autocorrelation parameter or any sort of kind of spatial correlation measure, we can pick up this spatial measure without any, you know, sophisticated extensions to the model. So simply just using the k-means, we can you know, get away with including spatial objects and spatial data.
Okay, great. Okay, no, that's useful. You know, it's a bit beyond what we're talking about here, but I'll add some links into the workbook if you want to go further with that. So we going back to the internet user classification. So we've got our outputs and the pen portrait here, and we've got a few examples on the slide here. Could you take us through what we've got on here, please, Jacob?
Sure. Yeah. So this is exactly what we were speaking about in the previous slide. So what you can see here is an example of so if we look at the data sets on the right-hand side, the bottom right corner there is exactly the output of the types of clusters that we would get. So based on, excuse me, all of our input data, which is, you know, any number of variables that we have, then the output of this is that the k-means algorithm finds 10 cluster groups based on our diagnostics and, you know, our model selection process. And then within these 10 cluster groups, what we can do is to look at the mean value of all of the input variables. And so here we just have an example of, you know, 4 or 5, but we have a table going across of all of the different input variables representing internet infrastructure and internet use. So we can see, for example, cluster group 1, that would be an example of kind of cultural creators. You know, on average, less of them own a desktop, more of them own a laptop. They have, you know, relatively, you know, kind of high download speeds relative to other groups. So these are the sorts of analysis that we can make based on the mean value. Just above that, that's the actual output of the cluster. So our LSOAs are our observational units. That's just the row of our data set. And you can see kind of the group that the LSOA is assigned to. And then the charts on the right-hand side are just a visual representation of the data that we get, so the mean value. So for every of the cluster groups, so this is group 1 and group 2, just kind of stacked together. So for each group, we can just plot the average values of the input variables. And then using that is just a bit more of an easier visual representation than trying to kind of look at the patterns in the numbers.
Okay. And so in terms of these numbers, are these index scores? So 0 is average, and then positive is above average, and negative is below average?
Yes. So
okay.
All the input data has been scaled.
Okay. So looking at, you know, cluster 1, the own laptop 2.0, so that's, you know, saying they're double the average chance of owning a laptop rather than a desktop computer.
Yeah, so it'd be mean standardized.
Okay, yeah, no, that makes sense. And the names that we've got for the cluster groups are like e-cultural creators, e-professionals, and so on. Where do they come from?
So they come mainly, you know, there's some amount of background knowledge that needs to go into that, but again, you would need to kind of consult with the industry experts and the people that know the field the best. You kind of have to take it a bit subjectively. You look at the data, you kind of come up with an idea of what the data represents. But in terms of, you know, specifying a pen portrait with an interpretation and a meaning on that, you really would want to be kind of consulting the experts and the people that are, you know, aware of this kind of dynamics to make sure that you're really, you know, assigning a meaning that makes sense.
Yeah. So it's, you know, it's very much the data tell us this much, but we need to talk to some experts who can say, okay, does that data sound reasonable? What does it represent in reality, and does that match their kind of expectations?
Yeah, exactly. And a lot of that goes back to kind of understanding what your data is, what the limitations on your inputs are, what types of inputs you're using. So it kind of all kind of comes full circle.
Mm-hmm. Okay. And kind of on that note about limitations, what are the kind of limitations that we might have with these methods that we talked about?
So the main one, we kind of mentioned it before, is that, you know, it's not it is a cross-sectional clustering. So we just have a level of observations. For every observation, we have kind of a string of attributes of input data that we're using. And we're kind of doing a clustering at that, imaginary static point in time. So although it's not any sort of kind of dynamic in the sense of incorporating space or time, the benefits of the k-means is that the input variables are flexible. So you can get really creative in how you're going to define inputs depending on what the research question is. So if you want to explore a kind of a spatial or a temporal clustering of neighborhoods on trajectories or surrounding trajectories, you can think of ways to incorporate all of this into your input variables. And so this opens up a lot of possibility to explore a lot more kind of sophisticated dynamics than just cross-sectional with a string of attributes for one point in time, or a static timeless period, for example. So we could look at trajectories of housing prices, demographics, internet usage, for example. So how has this changed over time? How has the strength of this relationship changed over space? So we can build this in using our input data.
Okay, great. Any other kind of limitations or tips that would be good for people to know about?
So I would say a lot of this is mentioned there is really knowing your data. So you wouldn't want to just be applying the k-means without having explored the data first. So I would say a lot of the, knowing what types of input parameters to use, a lot of it is in terms of kind of knowledge and theory, but there is a statistical part of this as well. So you do want to make sure you do the, pre-modeling descriptive statistics. You want to look at your correlations. You want to make sure that you're choosing inputs that are not going to kind of statistically interfere with the model. So you don't want any correlation or collinearity between your input variables. You don't want too many input variables trying to capture the same thing. So I think a lot of it comes down to, before you get to the modeling, make sure that you want to, you know exactly what you're trying to model and the data that you're using to model this. And then the last point there's a couple of tips and tricks. We tend to like to work originally with odd numbers, and that's just a matter of in the points when you have ties. So if we start with 2 clusters, for example, then if you have an observation that it's kind of could go in either one, you have a tiebreaker, so you don't have any kind of a third group to break that tie. So generally speaking, what you want to do is to start exploring with 3 clusters, 5 clusters, 7 clusters, so that we don't have any kind of issues of observations potentially moving or being a tie and not kind of being assigned to the correct cluster. These are just kind of small little tips, but again, really the diagnostics and the theory should be kind of driving the model selection.
Okay, great. No, thank you very much for that, Jacob. It's great to go through the process and explore both in terms of the kind of what we need to think about in general, but also what we did for the internet user classification.
Yeah, it was great.
Great, and thank you very much for watching the video. Please do have a go at the workbook linked to this video. So in the workbook, we'll take you through the process of creating, using k-means cluster on some sample data to create a kind of internet-related classification. And if you do have any questions or comments, please do drop us a line. Thank you very much.